Students, now we are going to solve exercise 2.2 class 10 general maths question number 3. Now this is the question 6x square minus 3 minus 7x. We have to find out the zeros of the quadratic polynomial, then we have to verify the relation between the zeros and the coefficient. Now let's have a look how to solve this exercise 2.2 question number 1 Roman 3. Students, now exercise 2.2 question number 1 Roman 3. The question is actually 6x square minus 3 and minus 7x. Now we have to solve this one. Before that I will just change the equation, like not change, interchange the equation, like 6x square minus 7x minus 3. Now after that I'm going to solve this equation. Now student, look, after that 6x square, now here we're going to middle term the equation. So there is 3 into 6 18. So look here, there is 7 and there is 3 into 6 18. So here in the middle term I will write something like 9 minus 2. If I write 9 minus 2 means 7, and 9 2 is 18, 3 6 is also 18, and 3 into minus 6 into minus 3 18. There is 9 into minus 2 18 means minus 18. So this middle term satisfies the equation. So here I will write 6x square minus 9x plus 2x minus 3. Now just after that, if I take common 3x here, I repeat again, if I take common 3x here, then here 3 to the 6 and x into x square, and here 3 into 3 9. I repeat again, 3 to the 6 and x into x square, then minus, and 3 into 3 9 x. So here if there is nothing taking common, so taking plus 1 as common, so 2x minus 3. Now next part would be 2x minus 3 and 3x plus 1. This is the first part of this equation. Now student, look, this is px, this is about px given in the question. So px equal to, we have got 2x minus 3 and 3x plus 1. Now we have to find out the zeros of the equation. Then we have to write here for the zeros of px, therefore px equal to 0. Now if px equal to 0, students, so in place of px I may write this one, 2x minus 3 and 3x plus 1 equal to 0. If it is do so, then we can write here either 2x minus 3 equal to 0, then 2x equal to 3, then x equal to 3 by 2, or we can say that 3x plus 1 equal to 0, then 3x equal to minus 1, then here x equal to minus 1 by 3. This is the two zeros only we have got from the equation. Now student, we will write here that the two zeros of the px are 3 by 2 and minus 1 by 3. Now look here student, if these are two zeros, 3 by 2 and minus 1 by 3, so we can say that, so sum of the zeros, sum means here we can say that here alpha equal to 3 by 2 and beta equal to minus 1 by 3. So according to the formula we can say that sum of the zeros equal to minus b by a. This is the formula. After that, if I write here that alpha plus beta equal to minus b by a. Now look, alpha and beta if I put down here, then alpha is 3 by 2 and beta is minus 1 by 3 equal to minus b by a. Now if I take the LCM here, 3 to the 6. Now if LCM is 6, then 6 divided by 2 3, 3 into 3 9, minus 6 divided by 3 2, there is 2, so minus b by a. So next would be 9 minus 2 is 7. 7 by 6 equal to minus b by a. Now look here student, we can say that this is a is 6 and minus b. If I take minus on that side, it becomes, if I take minus on that side, it becomes minus 7. So b equal to minus 7. Our sum of the zeros is now over. Now we are going to solve the product of the zeros. Now next one would be product of the zeros. Product of the zeros. Product of the zeros. Product of zeros equal to c by a, the formula. So if it is the formula, then we can say here that alpha into beta equal to c by a. Now look, again here we'll use the formula that alpha and beta. So what is the value of alpha here? Alpha is 3 by 2 and beta is minus 1 by 3. So here c by a. Now look here, if I cancel 3 and 3 here, then answer would be minus 1 by 2 equal to c by a. Now student look here, this can be written, since the value of a is 6 but there is 2 only. So if I write like this, minus 3 by 6 equal to c by a, then look here, 3 1s are 3, 3 2s are 6, means we got half here. I repeat again, if I multiply both the numerator and denominator with 3, so we got 3 by 6. So if I write 3 by 6 means the value of a is 6 and value of c is minus 3. So this is our product of the zeros. Students, now we are going to solve exercise 2.2, question number 1, Roman 4. 4u square plus 8u. Now let's have a look how to solve this one. Now look student, 1 Roman 4. 1 Roman 4 is here. So here if I write, let pu equal to 4u square plus 8u. Now why I have written this one? In place of px, I have written here pu. Why? Because in the question there is u. That's why I have written here u. If there is x, then I will write here x. If there is z, then I will write here z. If there is y, then I will write here y. I hope you understand that. Now look, pu equal to this. So our next would be, next one. From here, if I take 4u common only, then answer would be, there is u. I repeat again, if I take 4u common from here, then answer would be 4u and there is 2. 4u into u means u square plus 4 to the 8, 8u. Now here we cannot use the middle term factorization. Why? Because there is only 2 term. There is no 3 term. If there is a 3 term like u square, u and some more values like constant, so we can use the middle term factorization. But there is only 2 terms, so this sum will be like this. Now after that, now we'll write here that for the zeros of pu, therefore pu equal to 0. Now what is the value of pu here? Value of pu is 4u, then u plus 2 equal to 0. So we can say that either 4u equal to 0 or u plus 2 equal to 0. Now look here, if 4u equal to 0, which means u equal to 0 by 4, and next one would be then u equal to 0, but here u equal to minus 2. So our zeros are, so we can write that therefore the two zeros are 0 and minus 2. This is our two zeros of the equation. Since student these two are the 0, so we can write here therefore alpha equal to 0 and beta equal to minus 2 according to the formula of the quadratic polynomial. Now if we compare, now pu, actually pu equal to what is the given equation, 4u square plus 8u. Now if we compare, we'll write here comparing the given quadratic, given quadratic polynomial, comparing the given quadratic polynomial with a, since there is u, so I cannot write here a square, I will write here au square. Au square plus bu plus c we have, then the next one would be comparing this value with this. Value of a is 4, so we can write here a equal to 4, b equal to 8, and c equal to 0. Nothing means 0. Now student, we have to find out the sum of the zeros, of the sum of the zeros, which means here formula is minus b by a. Now if it is sum of the zeros, so we can write here alpha plus beta equal to minus b by a. Now what is the value of alpha here? Value of alpha, look, value of alpha is 0, beta is minus 2, so we'll write here now value of alpha is 0 and beta is minus 2. Then here is also minus b by a. Now in the next step we can write here that minus 2 equal to minus b by a. But look here, what is the value of a here? 4, but here we have got only 1. So we can do one more thing here, that if we go for the multiplication, both the numerator and denominator with 4 will be easy for us. Now minus and minus cancel. If minus and minus cancel, so next would be 2b by a. Now look next part. Now look here student, there is 2 by 1 equal to b by a. Now if I multiply both the numerator and denominator with 4, then there could be 8 and there is 4 by b by a. Now look student once, value of a is 4, value of b is 8. Now look, does it match with the given equation? See, value of a is 4, b is 8, which means sum of the zeros is correct. Now student, we are going to solve that product of the zeros. Now look how to solve this one, product of the zeros. Look here now. product of the zeros equal to c by a. Now product of the zeros means alpha into beta equal to c by a. Now what is the value of alpha here given? Look, value of alpha is 0 and beta is minus 2. So let's have a look. Alpha is 0 and beta is minus 2 equal to c by a. Now we can write here that 0 into minus 2 means 0 equal to c by a. Now next would be value of a is 4, we know that, so we can write 0 by 4 equal to c by a, which means if I write 0 by 4, this ultimately is 0 only, so a equal to 4 and c is equal to 0. So this is our actual answer, I guess. Now let's have a look once. Before that, look here, sum of the zeros means a is 4, b is 8, and here product of the zeros, a is 4, c is 0. Now which means a4, b8, c0. So let's have a look now, does it really match with the given equation or not? Look, a4, b8, c0, this is the answer, which means sum and products of the zeros of the given equation are correct. Now student, we're going to solve the exercise 1 Roman 5. The question is actually 1 Roman 5 question is t square minus 15. This is the question. So since it is t, so we'll write here let p in bracket t equal to t square minus 15. As I already told in the last video that if it is x here, then we'll write here x. If it is u, then we'll write here u. If it is t, then we'll write here t. So pt equal to t square. So now this t square and 15 can be written root over 15 whole square. If I write like this, then this could be a square plus minus b square formula. So a plus b and a minus b, by using the formula a square minus b square equal to a plus b, a minus b. If I write here root 15, square root cancel, 15 will be given, will be here, and t square, and it is as a whole a square minus b squared, so a plus b, a minus b means t plus root 15, t minus root 15. Now after that student, since pt equal to, we have got this value, so we'll write here that for the zeros, for the zeros of pt, therefore pt equal to 0. If pt equal to 0, then in place of pt we'll write this value here. So we'll write here t plus root over 15 and t minus root over 15 equal to 0. Now in the next part, if I write here either t plus root over 15 equal to 0, so t equal to minus root over 15, or t minus root over 15 equal to 0, so t equal to plus root over 15. This is the value of t only. So we can say that in the last line we can say that therefore the two zeros therefore the two zeros of pt equal to, or you can say that r minus root over 15 and root over 15. Up to this much the first part only. Now we are going to solve the relation between the zeros and the coefficient. Now student, we'll write here after that alpha equal to 15, alpha equal to root over minus 15 and beta equal to root over 15. Since we can say that since pt equal to, what is the given equation, t square minus 15, this is the given equation of pt here. Now if we compare comparing p comparing with a t square, since there is t, that's why a t square plus bt plus c, we get so a is a t square, there is nothing means 1, so a equal to 1, b nothing means b equal to 0, c equal to minus 15, c equal to minus 15. Now student, look, we'll write here that sum of the zeros zero, sum of the zeros equal to minus b by a. So sum of the zeros means alpha plus beta equal to minus b by a. So alpha is minus root over 15 and beta is plus root over 15, so minus b by a, so these two cancel, so answer would be 0 only. 0 means minus b by a, so next one would be 0 by 1, we can write 0 by 1 and minus b by a. Now look here, value of a is what, here in the value of a is 1, look, value of a is 1, so 0 can be written 0 by 1, so value of a is 1 and b is 0, so we can say that here we can use the last line 0 by 1 equal to, since it is minus b, so we can write here coefficient of, here the polynomial is pt, so we can write the coefficient of t by coefficient of t square. Since the polynomial is pt, that's why we have written here t and t square. This is the part of the sum of the zeros. Now next one would be, we're going to solve that product of the zeros. One more thing I must will say here, that look, once the value of a is 1 and minus b is 0, so let's have a look whether it is matched or not. Yes, it is matching because a is 1 and b is 0, which means the sum of the zeros is correct. Now next one is product of the zeros, product of the zeros, which means c by a. Now look, c by a, so product of the zeros means alpha into beta, and there is a c by a. Now look, alpha is minus root over 15 and beta is root over 15 and c by a. Now if I go for the multiplication here, minus root 15 and root 15 means root 15 square, and c by a will be here, so square root cancel, answer would be minus 15 equal to c by a. Now in the last line we can write here minus 15 by 1 we can write, and c by a. Now look, a is 1 and c is minus 15. Now does it match with the given equation? Let me check once. Yes, c is minus 15, b is 0 and a is 1. So here also we have got the answer, like c is minus 15, a is 0. So in the last line we can use the one formula, or you can say that the sentence here, that c means constant term, so we write here constant term by here a means coefficient of t square. This is the answer of question number 1 Roman 5. Students, now we are going to solve the last sum of exercise 2.2 question number 1 Roman 6. Roman 6 is the last sum of question number 1. Now here I will write that the 1 Roman 6 and 3x square then minus x minus 4. This is the question given, so we are going to solve now one by one. Here I will write let px, since here it is x, so I have written here x, px equal to 3x square minus x minus 4. Now look here, since there is three terms, so we can quadratic polynomial, so we can apply here the middle term factorization. Now look, 3x square, now there is 3 and 4, 3 fours are 12. So here I will write in some I will write the digits in such a way so that if we subtract or add we'll get 1 here, or if we multiply we'll get minus 12. Now let's have a look. If I write here 4 minus 3 means 1, and 4 3s are 12. 4 and minus 3 is minus 12, so minus 4 and 3 minus 12. So this value satisfying the middle term. Now look, 3x square then 4x minus minus plus 3x then minus 4. Now look, from here if I take only x common, so here would be 3x minus 4, and there is nothing to take common, so take 1 only, then 3x minus 4. So next would be 3x minus 4, and there is x plus 1. Now after that, this is only the middle term portion. Now after that, for zeros of px means polynomial, therefore px equal to 0. Now after that, if px equal to 0, what is the value of px here? 3x minus 4 and x plus 1 equal to 0. Now either 3x minus 4 equal to 0, then here we can write here 3x equal to 4, then x is equal to 4 by 3, or x plus 1 equal to 0, then x equal to minus 1. Now 4 by 3 and minus 1 are the two zeros of the polynomial px, so we can write here the last line, therefore the zeros of px are 4 by 3 and minus 1. This is the answer of the given polynomial. Now after that, students, now we can write here that here alpha equal to 4 by 3, beta is equal to minus 1. Now we are going to solve the relation between the coefficient and the zeros. So these two are the zeros. Now px equal to 3x square minus x minus 4. Now if we compare this value, comparing the given polynomial with ax square plus bx plus c, we have a equal to 3, b equal to minus 1, c equal to minus 4. Now we are going to find out the sum of the zeros and the product of the zeros after that. Now let's have a look how to solve this one. Look now, if I write here sum of the zeros, I'm writing here sum of the zeros equal to minus b by a. Now what is the sum of the zeros here? Means alpha plus beta equal to minus b by a. Now what is the value of alpha here? We have to check once. Value of alpha is 4 by 3 and value of beta is 1. Now minus b by a. Now if I take the LCM here, then LCM is 3 and 4 minus 3 will be here. So next would be minus b by a. Now next part would be 4 minus 3 is how much? 4 minus 3 is 1. 1 by 3 equal to minus b by a. Now look once after that. Here is the value of a is 3 and minus b is 1. Now we have to check whether it is matches with the given equation or not. Look here, after comparing we have got a is equal to 3, b minus 1, c minus 4, which means here in the sum of the zeros we have got a is 3 and b is minus 1, which means it matches with the given equation, which means the sum of the zeros is correct. There is minus b. If I take minus on that side, it becomes minus 1 b by a. Now look here in the last line, I can use one sentence, or you can say that the formula actually. There is minus, we can write there coefficient of x, and here you can write that coefficient of x square. This is the answer of the sum of the zeros. Now after that, product of the zeros. Now let's have a look how to solve the product of the zeros here. Now look student, just after that, product of the zeros equal to c by a. Okay, now after that, product of the zeros means alpha into beta equal to c by a. See, if it is c by a, then alpha is 4 by 3 and beta is minus 1. So here c by a only. Now after that, if I go for the multiplication here, then minus 4 by 3 equal to c by a. Now look after that, here c is minus 4, a is 3, which is it satisfies the given polynomial. So we can write here that minus 4 by 3 equal to, here constant term by coefficient of x square. This is the answer of the given question. Now student, we are going to solve that exercise 2.2 question number 2. Find the quadratic polynomial each with the given sum and products of zeros are respectively these are the, which means sum is 1 by 4 and product is minus 1, which means alpha plus beta is 1 by 4 and alpha into beta is minus 1. And this question is converts of question number 1. In question number 1, equation is given, we have find out the zeros, and here in zeros are given, means sum and products given here, and we have to find out the quadratic polynomial here. So the standard form of quadratic polynomial is ax square bx plus c. So let's have a look how to solve this one. Question number 2. One more thing students, I must will say here that question number 2 and question number 3 in this book question number 3 is not given, but in some books I have seen that in exercise 2.2 question number 1, 2 and 3 is there. So if you can solve question number 2 properly, then you can solve question number 3 also. So since question number 3 is not given here in this book, that's why I am not going to solve this one, but don't take tension. If you can solve question number 2, which means you can solve question number 3 also in new book. In some new book I have seen that there is a question number 3 also. So don't take tension. If you can solve question number 2, then you can solve question number 3 also, quite similar. Now we are going to solve question number 2 now. Now student, I am writing here 2 Roman 1 question is given 1 by 4 and minus 1. Now look, sum of the zeros equal to 1 by 4. Now look, sum of the zero means, according to the formula, sum of the zero means minus b by a equal to 1 by 4. So here b equal to, so we can say that here b by a equal to minus 1 by 4, which means value of b is 1 and minus 1 and a is 4. This is the sum of the zeros only. Now after that, product of the zeros. In the same question, product of the zeros. Product of the zeros. Product of zeros equal to minus 1. Now product means alpha into beta. Alpha into beta means c by a. So we can write here c by a equal to minus 1. Now here we can write like this, c by a equal to minus 4 by 4. If I write, so 4 and 4 cancel, we will get minus 1 only, so which satisfy the product of the zeros. I repeat again, it is given minus 1, so c by a, since a is 4, which means we have to make here also 4, so there is only one way out. If I divide minus 4 by 4, we'll get the answer, which means it is clear now, a is 4, b is minus 1 and c is minus 4. So our required equation, so in the last line we can say that therefore the required quadratic polynomial equation or quadratic polynomial is x square. X is ax square. Ax square means 4x square, then bx, value of b is minus 1. Look here, value of b is minus 1, so minus x and c is minus 4. This is the equation, this is the answer of the quadratic polynomial. Now look here student, the next one is question number 2, Roman 2 here. Question number 2 is Roman 2, given that root 2 and 1 by 3 here, root 2 and 1 by 3. So this is the sum of the zeros. So we'll write here again here, sum of the zeros equal to root 2 is given. So sum of the zero is minus b by a equal to root 2, and product of the zero is wait, I am now going to show you here. Look here now, product of the zero I'm writing here, product of the zero equal to 1 by 3, and here it is c by a equal to 1 by 3. Now look here student, value of c is 1 and value of a is 3, so here sum of the zero, it is minus b by a equal to 2. So here in the next step, if I write minus b by a equal to, if I write root 2 by 3, and if I multiply both the numerator and denominator with 3, which means, so look here, a equal to 3 and b equal to in the next time b by a equal to minus 3 root 2 by 3, and here product of the zero is c, which is 1, a is equal to 3, which means look here now, b, value of b is minus 3 root 2 by 3, a equal to 3, sorry, b is minus 3 root 2, a is 3, and c is 1, a is 3. So we can say, sorry, we can write here that the required quadratic polynomial is ax square bx plus c is the standard form. Now ax square, a is 3, which means 3x square, bx, now what is the value of b here? B is minus 3 root 2, so we'll write here now minus 3 root 2x, and c is 1. This is the answer of the question number Roman 2. Now student, we are going to solve that question number 2 Roman 3. Question number 2 Roman 3 here. The given part is 0 and root 5. 0 and root 5. Sum of the zeros here. Sum of the zeros equal to minus b by a. So sum is given here 0, which means minus b by a. So one more thing is that we can write here 0 by 1 equal to minus b by a, or if I write here only 0 by 1 equal to b by a will be also okay. There is minus b by a equal to 0 by 1, so next step b by a equal to 0 by 1. Now if I take 0 by, if I take minus on that side, 0 by minus 1 or will be also 0. So 0 by 1 is b by a only. Now next one would be product of the zeros, product of the zeros, product of the zeros, product of the zeros equal to c by a. Now product is given here, value of product is given here, root 5, root 5 equal to c by a. So here also we can write here root 5 by 1 by c by a, which means a equal to 1 and c is root 5 and b equal to 0. So our required, therefore we can write here the required quadratic polynomial, polynomial is ax square. Ax square means value of a is 1 only, so we'll write here x square plus bx. B is 0 actually. If b is 0, so we write here 0 into x and c equal to root 5, or directly we can write x square plus root 5. Correct answer. Now student, look here, Roman 4, 2 Roman 4, 1 and 1 is given. So now I am writing here only alpha plus beta here. Why? Because we know that it is sum of the zeros. That's why alpha plus beta equal to minus b by a. So alpha plus beta is 1 here. 1 means sum is here 1 and minus b by a. So this can be written as this can be written 1 by 1 equal to minus b by a, or in the next step we can write here that if I take minus on that side, so minus 1 by 1 equal to b by a. Now here in that part, if I write here product of the zeros, product means alpha into beta, product means c by a, so product is also given here 1, so c by a. Now in the next step, if I write here 1 by 1 equal to c by a, which a is equal to 1 and c is equal to 1. So our required equation would be, one more thing students, a 1 here and b is minus 1, here is a is 1 and c is 1. So our required equation would be, so we'll write here, therefore the required quadratic polynomial is, so actually the standard form of the quadratic polynomial is ax square bx plus c. So ax square means only x square, b is minus 1, so minus x, and c is 1, which means this is the answer. Student, now I am writing that 2 Roman 5 and the given equation is the given zeros, sum of the zeros is minus 1 by 4 and product is 1 by 4. Now I am writing here that a simple alpha plus beta. I am not writing the sentence. Alpha plus beta is minus b by a, which means sum of the zeros equal to minus b by a. So this value is given here 1 by 4 and there is minus b by a. Now in the next step, minus minus cancels, so here 1 by 4 equal to b by a, first one. Now here alpha into beta means product of the zeros equal to c by a. Product of the zeros is also given 1 by 4 here, then c by a. Now a is 4, c is 1, here is a is 4, b is 1. So our required equation would be, so write the last line, therefore the required quadratic polynomial is ax square. A is 4, which means 4x square, b is 1 plus x, and c is 1 also, which means 4x square plus x plus 1. This is the equation. Now student, we are going to solve the last one, question number 2 Roman 6. Question number 2 Roman 6. The question is given 4 and 1, which means sum is given here 4. Sum means alpha plus beta means sum of the zeros equal to minus b by a, and alpha plus beta is given here 4, which means minus b by a here. And look, alpha into beta means product of the zeros. Product is given here 1 and formula is c by a. So product is given here 1, then c by a. Now look, there is minus b and there is 4, so we can write 4 by 1 equal to minus b by a here. And in the next step we can write that if I take minus on that side, so minus 4 by 1 equal to b by a here. and there is c. So next step we can write here 1 by 1 equal to c by a. Now look here, after that a is 1, b is minus 4, c is 1. So our required last line, therefore the required quadratic polynomial is, the standard equation is for ax square bx plus c. Ax square, a is 1, which means x square, b is minus 4. So we'll write here x square minus x, and c is 1. This is the answer of the last question.